Hey everyone, and welcome to my free CCNA Cisco Certified Network Associate course. So today we are going to be discussing about VLAN. So what we are going to be doing today, our main objectives are going to be what is VLAN and how it works. We're going to understand how do inter-VLAN communication happens, how do we configure it, what are the various VLANs that are available with us, and in which scenario we use which VLAN type. And there are some Cisco proprietary protocols for VLANs. As you know, Cisco was the first one to develop VLAN and it was known as ISL. So there are some Cisco proprietary protocols in our Cisco switches. How do we configure them? Do we need to configure them? Do we need to understand them for this course? What all is there? We're going to understand that, and in the end we are going to see how we can use Cisco command line to debug everything. But first, let's understand what is VLAN. VLAN is short for virtual LAN, which is defined under IEEE 802.1Q. So VLAN is basically used to divide a layer 2 broadcast domain. That is, if we have a switch which is working under a single broadcast domain wherein all the hosts are in the same broadcast domain, we can use VLAN to divide these hosts in different broadcast domains. Why do we do this? We do this because we want to implement different policies for each of the domains. That is, for example, if you are in a school, you want to implement different policies for your students and you want different policies for your teachers. So VLAN helps in segregating the traffic in this way. And since this is a logical separation, we do not need any extra hardware. Our existing Cisco switches can do this. So the other reasons why we need to divide this broadcast domain is that, so if we have everyone on the same broadcast domain and if one host is broadcasting the traffic, all the other hosts are going to get affected, and in turn our switch infrastructure is also going to get affected because our switches will be using unnecessary CPU while broadcasting and while processing all that broadcast. So it is always good that we separate broadcast domain as per departments. It is not a good idea to separate broadcast domains basis of the geographical location, but in certain conditions geographical separation may be required, but that should be used as a last resort. Segregating as per department in an enterprise network will help you define security policy also for each separate broadcast domain. So teachers is going to have a separate security policy, students are going to have a separate security policy, and the administration is going to have a separate security policy. And last but not the least, smaller broadcast domains means smaller footprint to detect where the problem might be, and that will result in a quicker problem solution. So let's just go through this diagram right now and see how the VLAN works. So VLAN is an additional tag in the layer 2 frame. So in this diagram, the router is sending multiple VLAN, that is VLAN 100, 10, 20 and 30 to the network, and the distribution switch is segregating these VLANs on different LAN segments. That is, it is getting all the 4 VLANs, but while forwarding it to access switch layer, the distribution switch is sending 100 as a common VLAN and 10, 20, 30 on different LAN segments. And subsequently access switch is just transferring 10, 20 and 30 VLANs forward to the customers, and it is not forwarding VLAN 100. So in this diagram, if you see, VLAN 100 is basically the management VLAN, wherein that is basically used to manage a device, that is our distribution switches and access switch. And VLAN 10 is the first department, VLAN 20 is the second department, and VLAN 30 is the third department. So let's now switch over to our whiteboard and see where this VLAN tag gets added. So this is what our Ethernet frame looks like, and it has two main components, that is the destination address and the source address. That is the destination MAC address and the source MAC address, and this is what is used when the frame is forwarded from one host to another host. Now after this, there is a small indentation that happens here. A fresh information is added to the Ethernet frame, and that is known as tag. This tag is 802.1q VLAN information. Now, as I told you before, there are some Cisco proprietary protocols in Cisco switches because Cisco was the one which came up with the VLAN. It was not known as 802.1q VLAN, it was known as ISL, which is known as Inter Switch Link. It still exists in some of the Cisco switches, but when you connect with ISL to VLAN 802.1q, they are not going to be able to communicate. Although the information in both the case is of 2 bytes, but the communication will not happen. So make sure that if you are on 802.1q, the other side is also on 802.1q. If the one side is on ISL, then the other side is also on ISL. Now in this 2 bytes of data, there is first is known as type, which defines whether this is 802.1q, is it ISL, or is it some other manufacturer standard. So if it is 802.1q, this will be set at 80x8100. So this information is purely for knowledge so that you understand what all data this tag information contains. The next is PCP. PCP is priority code point or priority, and this priority contains 3 bits of data which defines the class of service. We are going to understand this later on when we study about quality of service topic in the CCNA course. So this defines basically if the data is high priority, low priority, mid priority, what kind of class of service or priority this particular frame has. The DEI is a flag that is set that if there is a choking happening, particularly at this point on the switch, can we drop this traffic or not. So it is either set at 0 or 1, and this is 1 bit of data. And the last and the most important part that affects us is the vlan-id, and this is 12 bit of data that concerns us, and this is what we configure in our switches and in our devices to identify which traffic is which. And this 12 bit of data is can be tagged from 0 to 4095. That is a total of 4096. So this VLAN range, which give a 4096 IDs, each of these IDs are not usable. Some are reserved, like 0 and 4095 are reserved and are for system only. We cannot use them. And by default, all these switch ports come tagged with VLAN 1. And this is normal in not only Cisco but other brands also. VLAN 2 to 1001 is the VLAN that we can use to create, edit and delete as per our requirement. VLAN 1002 to 1005 is again normal range but cannot be used in Cisco because it defaults to FTD and token ring in certain catalyst switches, and it is better if you will not use it, because if you have legacy switches in your network and you are using these VLANs in the new switches, you may be able to use them, but it will cause problem when you need to pass it through the old legacy switches. The last range of 1006 to 4094 is the extended range, is the same as the normal 2 to 1001, which you can use to create, delete, edit as per your requirement. So basically what you need to learn so basically what you need to know is a range from 2 to 1001, and 1006 to 4094 is the range of VLANs that you can use to configure your network. And for a normal enterprise network, this is enough. So enough of theory, let's get into our Cisco switch and let's configure it. So I'm going to use packet tracer today. So in Cisco Packet Tracer, I've added 296024TT as my switch. So let's open this switch in the console and let's enter the enable mode and let's enter the configure terminal. And in this, to configure VLAN, to add a VLAN, all we need to do is specify the VLAN that we need to add. And if you want to give it a name, we give it a name. Say we are adding VLAN 100 for student, and in the same we can add VLAN 200 and we can name it teacher. So now we have added two VLANs. To see what VLANs we have added, we use the command show VLAN brief, and we see that we have added two VLANs here, that is VLAN 100, that is the student VLAN, and VLAN 200, that is the teacher VLAN. We also see that by default there was a VLAN 1. As I told you, all the switches that come from factory by any OEM have VLAN 1, and there are some VLANs which are reserved with Cisco legacy products. So VLAN 1002, 345 are reserved. But our VLAN show here, we can use the command show VLAN brief, and it shows that which VLANs are there, what is the name of that VLAN, whether that VLAN is right now active or not, and what are the ports associated with that VLAN. So currently we have just added the VLAN, but we have not added any port to it. There is another way of adding VLAN, that is through VLAN database in the enable mode and not the configure mode, and this VLAN database can be modified directly through the enable mode, and you enter this prompt which is switch VLAN, and under this you can add VLAN and the name of that VLAN. This is not available in Packet Tracer and it is not available in all the switches. Sometimes people have a misconception, and what they accidentally do is they go into the configure mode and they say interface VLAN 3 and the VLAN ID. If you're adding a VLAN like this will not add a VLAN, this will just create an interface VLAN 300, but it will not create a VLAN 300. So if we create, say, a description here, this is VLAN 300, and if we get out and we try to see what all VLANs we have, you see that we have only VLAN 100 and 200 that are being listed, but VLAN 300 doesn't comes. But if we see show running, we see that interface VLAN 300 is there in configuration, but it will not show in the VLAN because we have not added VLAN, we have just added an interface VLAN. This is a layer 3 thing. So to add a layer 2 VLAN, we need to give VLAN and then the VLAN ID. So don't make this mistake. Many people do make it. I know that I have made it in past also. Now that we have added VLAN, how do we add ports and which port do we assign which VLAN and how do we configure that? So to understand this, first we need to understand there are different types of VLANs. So the first is access VLAN. Now the access VLAN is the VLAN which has only one VLAN on one port. That is, if you are connecting your computer directly to the switch, it is the computer doesn't knows what is VLAN tagging. Although in some computers you can do VLAN tagging, but there is no point of doing VLAN tagging on those computers. But you want a computer to just talk to one port on the switch. So on that particular switch, if your student has plugged in their computer, you want to make that as an access VLAN port. So the traffic that is going to come into that is going to carry no VLAN tags, but is going to be tagged once it enters the switch. And when the traffic is leaving the switch, the tag is going to be removed so that the computer can understand the traffic. And as I said, we usually assign access VLAN to endpoint device like our computers. So let's understand how do we configure VLAN. So in our case, let's assume that we have on interface fast Ethernet 02 for a student computer. So to configure this, we go into the configure terminal and we enter the interface fast Ethernet 024. Now in this, the first thing that we are going to do is switch port mode access. We are going to tell the switch that this port is going to act as an access port. The next thing that we are going to do is we are going to make this into the VLAN 100 tag that we had created for our student. So switch port access VLAN 100. So now this port is part of 100 VLAN, but the traffic that is going to exit from this port is going to be without any tag, but the traffic that comes into this port untagged is going to be tagged as VLAN 100. Now ideally you do not have to remember the VLAN ID and you can do switch port access VLAN name and then the name of the VLAN. In our case it was student. Unfortunately in packet tracer, if you execute this command, you're going to be returned an error. It doesn't understand this command, but in normal Cisco switches this command will work. So to verify this configuration, now let's do a show a VLAN brief once again and let's see. So now we see that fast Ethernet 024 is now associated with VLAN 100, whereas fast Ethernet 24, which was earlier with VLAN 1, is no more there. So as I said, you can add VLAN both by ID and by name, and only thing you need to do is use the correct syntax, that is switch port access VLAN ID or name VLAN name. If it doesn't work with packet tracer, it's okay, but you should still remember these commands. It is very essential for your exam purpose. So before we get into the second VLAN type, that is the trunk VLAN, we need to understand some Cisco proprietary protocols. The first one is VLAN Trunking protocol. Now VLAN Trunking protocol is a Cisco proprietary tool which is loaded on all the Cisco switches. And what happens in this is if you will configure a VLAN on one switch, it will automatically get configured on the other switch as well. Now for purposes of CCNA, this is an advanced topic and this is going to be discussed more in CCNP track. For your labs, what you can do is in global command mode, you can do a VTP mode off or VTP mode transparent to shut VTP. But all you need to know right now is the VTP is a Cisco proprietary tool, and if you configure VLAN in one switch, it gets configured in another switch as well. The other proprietary protocol that you need to know about is dynamic trunking protocol, that is DTP. Now DTP is used to negotiate trunking or access port between switches. So if you have switch on one end connected to switch on another end, so whether the port that they are connected on are going to act as trunk or access, this can be negotiated automatically between the switches using dynamic trunking protocol. So VTP, when you were configuring VLAN on one switch, it got automatically configured on the other switch, whereas in DTP, the switches are negotiating whether they want to act as trunk port or an access port. You can also switch off dynamic trunking. It is not forced that you need to enable it, but there are certain modes in DTP that you need to understand. So like we right now configured a switch port mode access, that was to define that this was an access port. We can define statically that this is a trunk port. A trunk port is the port wherein you carry multiple VLANs, and it is usually used as switch to switch communication where you are passing VLANs from one switch to another switch so that they can further transmit or further transfer this to another switch, or they can have an access port on them and distribute it to the endpoint. The DTP is configured by either dynamic desirable or dynamic auto. In dynamic desirable, the negotiation message is sent also and is responded to as well. That means that if you set the port to dynamic desirable, the switch is going to initiate a negotiation message, that is, tell the other switch that hey, I'm available and I want to negotiate with you. And if any other switch contacts it, it's going to respond to it that yes, I want to negotiate with you. So both the things are going to happen in dynamic desirable. But in dynamic auto, the switch is never going to initiate the negotiation. It is just going to respond to any negotiation message that is going to come to it. This is a passive mode. So if you have two switches which are on dynamic auto, they will not trunk, they will have, the ports will be stuck on access mode only, because these switches are only listening and they are not talking. Had one of the switches said that I want to negotiate on trunking, then the other dynamic auto switch would have said yes, we can trunk. But right now this will not happen because both the switches are on dynamic auto. So let's see this thing on the whiteboard. We have a switch here and a switch here. If we have an access port here and we configure an access port here, the communication will happen without any problem. But in case we plan that we don't want an access port here but we want a trunk port here, but we don't configure this switch as trunk, then there is going to be a problem. The communication will suffer because one port is access and the other is trunk. But if we say that on this switch also that we want to have trunk port, then the communication will happen. But in both access and trunk, this is a static configuration that you are doing. This is not a dynamic configuration that is going to happen. For dynamic configuration, if one side is set to dynamic auto and one side is set to dynamic desirable, so in this case what is going to happen is this side of the switch, that is this switch, is going to send a initiate message to the other side and the other side will respond back and they will both form trunk. But in the case that we say that both the switches are at dynamic auto, there is going to be no initiation of the trunking negotiation from any of the sides. So both sides will be set to access mode. And lastly, in the case if we have a dynamic desirable at both the ends, so the initiation can happen from any end, and whichever end receives this initiation of negotiation, the response will be sent. There is going to be no problem that both the sides are initiating it and both the sides are responding it. The result is going to be the same. Both sides will form a trunk mode. So this chart will help you in troubleshooting and you will need this for your exam as well. Let's switch to our Cisco switch and let's see how we can configure all these modes. So let's enter the configure terminal and let's enter the interface gigabit 01, and on this interface if we say switch port mode, we question mark, we see that we have options of access where we can statically configure it as an access port. We have an option of trunk wherein we can statically define it as a trunk mode. That means that we are connected to another switch and we are passing a bunch of VLANs, not just one VLAN. And the last is dynamic. So we can set the mode to negotiate automatically. So dynamic, auto, or desirable. So remember, in auto is passive and desirable is the active mode. That is, if you set it to desirable, the initiation is going to happen, and if you set it to auto, it is just going to be listening. So let's come to trunking now. This is usually configured on the point if you are passing a bunch of VLANs to another switch. This trunk can be either 802.1q or it could be an ISL. So to manually configure this 802.1q or ISL or negotiate with the switch, we use the command switch port trunk encapsulation either DOT1Q, that is 802.1Q, ISL, that is for interswitch link, that is Cisco proprietary, or we set it to negotiate so that the switches can negotiate amongst themselves. Again, unfortunately, this command does not work in packet tracer. So you can run this command on an actual Cisco switch. I'll just show you this on a Cisco switch. So if you see this switch port trunk encapsulation, and we get an option of either doing a DOT1Q, which is 802.1Q trunking encapsulation, ISL, which is ISL trunking encapsulation, or the device will negotiate amongst themselves which trunking encapsulation is to be used. So let's go back to our packet tracer and let's configure our gigabit ports so that they act as trunk ports for passing VLANs from one switch to another switch. So let's put out another switch here and let's link these two switches with a Ethernet cable on port gigabit 01 and on the side also gigabit 01. So we see that the line protocol on gigabit Ethernet 01 has changed it to up. So let's enter the configure mode now and interface a gigabit Ethernet 01, and in this we are going to define the switch port mode trunk. We are going to define that this switch is going to act as a trunk. The next thing that we want to do is we want to say switch port trunk allowed VLAN, and here we can allow VLANs 100 and 200 to pass between both the switches. So now essentially what we have done is we are passing VLAN 100 and VLAN 200 as a tag traffic on gigabit Ethernet 01. So let's configure our other switch also, and let's configure the gigabit interface on this as switch port mode trunk, and let's say switch port trunk allowed VLANs as 100, 200. So now this switch also is trunking all VLAN 100s and 200s. So let's expand the network a bit and let's put some endpoint devices so that we can simulate a teacher network and a student network. So what we are going to do is PC0 and PC2 here are going to act as our students. So student 1, and this device is going to act as student 2, and this device we want to configure it as teacher 1, and this device we want to configure it as teacher 2. So let's give our student an IP address of 192.168 or say 100.1 and subnet is 255.255.255.0, and student 2, let's give it an IP address of 192.168.100.2, subnet mask 24, and let's connect these two PCs to the switch, and going to connect it to fast Ethernet here, and on the switch we are going to connect it to fast Ethernet 24, because if you remember we had configured fast Ethernet 24 on our switch 0 to act as an access port for VLAN 100. Similarly for student 2 also, let's connect student 2 to switch 1, fast Ethernet 0 on student 2 and fast Ethernet 024 on switch 1. Let's configure fast Ethernet 24 here. So interface fast Ethernet 024, and we want to configure this as switch port mode access. It's going to add switch port access VLAN 100. So we got an error which says that the access VLAN does not exist, creating VLAN 100 because we had not created VLAN 100. So let's enter VLAN 100 and let's give it a name of student so that there is no confusion, and let's also create VLAN 200 and name it as teacher. So now on both the sides we have VLAN 100 and VLAN 200 configured as student and teacher. Let's do a show VLAN brief, and we see that VLAN 100 is associated with fast Ethernet 24. So now ideally we should be able to ping from student 1 to student 2, and yes, we are able to. That shows that the traffic is going from student 1 to switch 0 from port 24, then from gigabit 01 to gigabit 01 or switch 1, and then from port 24 to student 2. Let's confirm this and let's change the port on switch 1 to port fast Ethernet 23, and let's configure this port as access port for VLAN 200. So configure terminal and interface fast Ethernet 023 switch port mode access switch port access VLAN 200. So now we have configured port number 23 as access VLAN for 200 and switch port 24 to access VLAN 100. Let's do the same thing on switch 0 also. So now both the sides switch port 23 are acting as access port for teacher. Let's connect this also. So here we are connected to fast Ethernet and here we are connected to port 23. But here what we are going to do is mismatch something. We are going to connect teacher PC to fast Ethernet, and we are going to connect here with fast Ethernet 24, which is actually the student port. Let's configure the IP addresses also. So let's put an IP address 192.168.200.1, and on the other side let's put an IP address of 192.168.200.2. So now ideally if we are to ping, we will not be able to ping. The reason behind that is because the student 2 on the other side is on or a wrong VLAN access port. So let's rectify this now. So let's remove this cable for a bit and let's rectify our ports. This is the correct port, and from student 2 connect to fast Ethernet, and here we are connected to fast Ethernet 24. So now it should work. Let's go to our command prompt and let's check this once more. Yes, the link is back up. Let's check the teacher also, and we're going to ping 192.168.200.2, and we can see that the teacher is also able to ping. So now you understand how VLANs work. So when we configure the trunk, we just said switch port trunk allowed and we just gave the VLAN IDs. So what we effectively did was on configure terminal in interface gigabit 01, we said switch port trunk allowed VLANs, and we give VLAN 100 and 200. So tomorrow if we add another VLAN, say VLAN 300, and we say that name is management. So what happens in this scenario now? So in this scenario, when you want to add this, so you're going to again write switch port trunk allowed VLAN 100, 200, 300, and then 300. Why? Because if you just say allowed VLAN 300, what's going to happen is, let's see the running configuration for our switch, and we see that gigabit 01 only allows VLAN 300. VLAN 100 and 200 work no more. Re-verify this by checking the student, and yep, the ping is gone. So reason behind that is in Cisco, when you configure the command switch port trunk allowed VLAN 300, it overwrote the earlier command which was allowed VLAN 100, 200. So to avoid this, the best thing to do is, instead of writing switch port trunk allowed VLAN and the VLAN IDs, what you can use is the word add or remove. Now this will only add that means append to existing list, and this will remove from existing list. What you can also do is add all the VLANs that are available currently in the database, and you can also do an exceptional thing, or you can add none. So let's do one thing. Let's right now add 100, 200, and we add VLAN 200. Now there are some commands that work in normal Cisco environment but don't work in Cisco Packet Tracer. Don't get frustrated. It's okay. This is a simulated environment. Now let's check our running configuration once more. So now we see that we have added, or we have appended two VLANs. We have added VLAN 100 and we have added VLAN 200, which are both now appended to VLAN 300. Now we did not issue the command switch port trunk allowed VLAN 100, 200 and 300. We said switch port trunk allowed VLANs add 100 and add 200. So this is an important command that you need to remember in case you're working in a live environment, because if you are using add and remove, this commands can be used to also automate if you want to insert new VLANs or you want to delete VLANs. And the last VLAN type that Cisco has is a voice VLAN. So what happens if you have a Cisco phone on one of the desktops and the Cisco phone has a desktop connected to it? So in that case, what happens is the voice VLAN has to be trunked and the data VLAN has to be access port. That means the port is going to work as a hybrid port wherein it has both the access VLAN and it's going to have a trunk VLAN. Because we are going to carry both the voice and the data on the same Ethernet cable and going to terminate it on the phone, and the phone further is going to be connected to the PC. So in this case, what we are going to do is we are going to make VLAN 11, let's name it voice, and in interface FA022, what we are going to define is this switch port mode access, and switch port access VLAN is going to be 200. So we are saying that this port is going to act as an access port for teacher, and also this is going to act as a voice. That means it's connected to a voice port, and the voice VLAN for this particular interface is VLAN 11. So this port is now a hybrid port. That means that the voice traffic is going to travel on VLAN 11 and the data traffic that is going to travel on VLAN 200. So the last VLAN that we are going to talk about is native VLAN. Now by default, a native VLAN on a switch is VLAN 1, and many people get confused when it comes to native VLAN. Native VLAN is basically the VLAN when the native VLAN is the VLAN which gets tagged to the packet which has no tag and is ingressing on any tagged port. So for example, we have two switches which have tag traffic running, that is VLAN 100, 200 and 300. Now switch 2 sends a packet which has no VLAN ID. What happens when it reaches switch 1? Switch 1 is going to ingress that packet into the network with a native VLAN. So this kind of acts as an access port to the untagged traffic. But this can act as a security issue in the network. So ideally, a native VLAN is set to a VLAN ID which is not in use. So unused VLAN ID is set as the native VLAN in the switches on trunk ports. So to configure this, let's enter into our switch interface GI01, which is the trunk port, and we configure this by switch port trunk native VLAN, and we give the VLAN number. Now this native VLAN has to be the same at both the ends. In case this is not same, switch is constantly going to be throwing errors that there is a native VLAN mismatch happening. Now this is not a problem, but this can cause some issues. What issues can come is, if we come back to the drawing board, so we have set VLAN 99 as the native VLAN ID here, but here the native VLAN ID is still 1. So what is going to happen is, the packet that is egressing as VLAN 99 from here, which is not going to carry any tag, is going to be tagged as 1 on switch 1. Now what is happening is, this is known as VLAN jumping. Basically the frame here is jumping from one VLAN to another VLAN because there is a misconfiguration happening. Now you see, in the switch we are being thrown a error which says that the native VLAN has a mismatch. That is, we have configured 99 on our part, and on the other end it is still configured as 1. So this is causing the packet to jump. So let's resolve this, and on the other end, that is switch 1, let's configure this as the same. Let's configure the native VLAN as 99 here also. So switch port trunk native VLAN 99. So now the packet is not going to jump one VLAN to another, and we will not receive this error message anymore. So while working with VLANs and while working on switch, you will have to debug regularly. So each show command will give you different information. So you need to be very well versed with what information comes from which show command. And this is just a hint that these are some things that you are tested on in your examination. So for example, we did show VLAN brief. Now what show VLAN brief gives us is all the VLANs that have been configured on the switch, the names, what are the statuses, and which ports are associated with which VLANs. Now in this case, only the access ports that are associated with the VLAN are given. So let's do a show VLAN question mark, and we get ID. So let's do VLAN ID 100. Now in VLAN ID 100 we see specific only for VLAN ID 100. We can also do name student, and we see the same information that is only for the student. And if we want to see cumulative for all the VLANs, we do a show VLAN. To see the current VTP status, we do show VTP status, and we see that this is currently working as a server because we have not disabled the VTP status. So VTP mode off, or we can do VTP mode transparent, as mode off is not available in packet tracers. So let's do VTP mode transparent, and now let's do show VTP status. So the status has changed to transparent. That means if there are any changes happening in VTP, the changes are not going to get affected on the switch. It is acting as a transparent. It is just passing the VTP information. The other is, we want to see the switch port configuration of the interface. So in our case, we want to see it for 01. So show interface gigabit Ethernet 01 switch port. So we see a bunch of information here. Switch port is enabled. That means this is a switched port. It is not acting as a router port. The administrative mode is set to trunk by default, and the operation mode right now is also trunk. The administration trunking and encapsulation is .1q, and the operation is also .1q. The negotiation of trunking is on. That means that it is sending out information that it is available for trunking. So if there is a dynamic auto port on the other side, it will automatically switch to trunk. The native VLAN mode, as we had set for 99 on this port, and the trunking VLANs that are enabled on this port right now are 100, 200, and 300. And we are pruning, that is, we are not sending any other VLANs on this port. So all this information is available while doing debugging, and show commands are something very essential that you need to understand, and this only comes through constant labbing. and you facing problems and you trying to resolve it at your end, and you will be able to see that which information or which show command gives you which information, and because of that you are able to debug. So I hope that you liked today's session. Please do press the like button. Please do subscribe to my channel to get the latest updates, and we will see you soon with STP.